Article 220.3b9 and Article 220.3b10 of the 2002 National Electrical Code, or NEC, address receptacle outlet limitations in sleeping rooms. Article 220.3b9 states that receptacle outlets installed for the convenience of the occupant of sleeping rooms shall be limited to those necessary for personal grooming, such as a receptacle for a toothbrush or hairdryer, and for operation of necessary equipment. A minimum of one receptacle outlet shall be required for each wall or partition and portions thereof that is more than 1.2 meters, or 4 feet, in width. Article 220.3b10 states that receptacle outlets installed for the operation of portable appliances not fastened in place shall not exceed 13 on any 15 amp or 20 amp branch circuit used to provide power for bedroom or bedrooms. The issue in question revolves around an inspector citing an electrician for having 13 outlets, encompassing both receptacles and lighting, on a single 13 amp circuit serving bedrooms with arc fault protection. The conflict arises from differing interpretations of the aforementioned NEC articles. The central point of contention is whether the 13 outlet limit specified in Article 220.3b10 applies solely to receptacle outlets, or if it extends to include light outlets as well. To properly understand the issue, it is crucial to dissect the language of each article carefully. Article 220.3b9 primarily focuses on the purpose and placement of receptacle outlets in sleeping rooms. It emphasizes limiting these outlets to those essential for personal grooming and the operation of necessary equipment. Additionally, it mandates a minimum of one receptacle outlet per wall space exceeding 4 feet. Article 220.3b10, on the other hand, explicitly sets a numerical limit of 13 receptacle outlets on a 15 amp or 20 amp branch circuit supplying power to bedrooms. It is important to highlight that Article 220.3b9 makes no specific mention of lighting outlets within its limitations. The wording explicitly refers to receptacle outlets, without extending the restriction to encompass lighting fixtures. Given this distinction, a strict interpretation of the code would suggest that the 13 outlet limit in Article 220.3b10 applies only to receptacle outlets and not to lighting outlets. Therefore, if the electrician installed 13 receptacle outlets along with additional lighting outlets on the 15 amp circuit, it may not necessarily constitute a violation of Article 220.3b10, provided that the receptacle outlets are arc fault protected. To provide a comprehensive understanding, let's delve into a detailed analysis of the relevant sections of the 2002 NEC. Firstly, it's important to understand the definition of an outlet. According to the NEC, an outlet is a point in the wiring system at which current is taken to supply utilization equipment. This definition encompasses both receptacle outlets, which provide a point of connection for portable appliances through the use of a plug, and lighting outlets, which supply power to luminaires or lighting fixtures. Now, focusing on Article 220.3b, this section of the NEC deals with branch circuit requirements. Branch circuits are the circuits that extend from the final overcurrent device protecting the circuit to the outlets. The specific subsections B9 and B10 address receptacle outlet limitations in dwelling units, particularly in sleeping rooms. Article 220.3b9 aims to ensure that sleeping rooms have an adequate number of receptacle outlets for the convenience of the occupants, while also preventing excessive use of power. The requirement of at least one receptacle outlet for each wall space greater than 4 feet ensures that occupants have readily available access to electrical power for essential devices. This provision primarily addresses the placement and accessibility of receptacle outlets. Article 220.3b10, on the other hand, is focused on limiting the total number of receptacle outlets connected to a single branch circuit in bedrooms. The limitation of 13 receptacle outlets on a 15 amp or 20 amp circuit is intended to prevent overloading the circuit, which could lead to overheating, nuisance tripping of the circuit breaker, or even fire hazards. The key to interpreting these two articles lies in recognizing that they address different aspects of electrical safety and convenience. Article 220.3b9 focuses on ensuring adequate access to receptacle outlets, while Article 220.3b10 focuses on preventing circuit overload. In the scenario presented, the inspector's concern appears to stem from the total number of outlets, including both receptacle and lighting, exceeding the implied limit. However, the code language specifically restricts the number of receptacle outlets, not the total number of outlets including lighting. Therefore, a strict interpretation would suggest that the inspector's interpretation is not entirely accurate. The electrician is permitted to install up to 13 receptacle outlets on the 15-amp circuit regardless of the number of lighting outlets also connected to the circuit. This interpretation is further supported by the fact that lighting outlets typically draw less current than receptacle outlets, particularly with the advent of energy-efficient lighting technologies like LED lighting. However, it is crucial to ensure that the total load on the circuit, including both receptacle and lighting outlets, does not exceed the circuit's capacity. The NEC provides guidelines for calculating the load on a branch circuit, taking into account the wattage of all connected devices and appliances. If the total calculated load exceeds 80% of the circuit's rating, which is 12 amps for a 15-amp circuit, then it may be necessary to reduce the number of outlets or increase the circuit size to ensure safe operation. It is also important to consider the specific requirements for arc fault circuit interrupter, or FSI protection in bedrooms. The NEC requires FSI protection for all branch circuits supplying outlets in bedrooms to protect against arc faults, which are a common cause of electrical fires. In the scenario described, the circuit is already arc fault protected, which provides an additional layer of safety. Based on this analysis, the consensus is that the inspector's interpretation of the NEC may not be fully supported by the code language. Article 220.3b10 specifically limits the number of receptacle outlets, not the total number of outlets including lighting. Therefore, the electrician should be allowed to have 13 receptacle outlets, plus any necessary lighting outlets, on the single 15-amp circuit, provided that the receptacles are arc fault protected and the total load in the circuit does not exceed the circuit's capacity. To provide a clear recommendation, it is suggested that the inspector reconsider their interpretation and engage in a dialogue with the electrician to ensure a mutual understanding of the code requirements. It may also be beneficial to consult with a qualified electrical engineer or NEC expert to obtain further clarification and guidance on this matter. In addition, it is important for electricians to carefully calculate the load on branch circuits to ensure that they are not overloaded. This includes taking into account the wattage of all connected devices and appliances, as well as any applicable demand factors. By following these guidelines, electricians can ensure the safety and reliability of electrical installations in sleeping rooms and other areas of dwelling units. In summary, the key takeaways from this analysis are: firstly, Article 220.3b9 addresses the placement and accessibility of receptacle outlets in sleeping rooms. Secondly, Article 220.3b10 limits the number of receptacle outlets on a 15-amp or 20-amp branch circuit in bedrooms to 13. Thirdly, the code language specifically refers to receptacle outlets, not the total number of outlets including lighting. Fourthly, the electrician should be allowed to have 13 receptacle outlets, plus any necessary lighting outlets, on the single 15-amp circuit, provided that the receptacles are arc fault protected and the total load on the circuit does not exceed the circuit's capacity. Finally, careful load calculations and adherence to NEC guidelines are essential for ensuring the safety and reliability of electrical installations. Now let us delve a bit more into the context of the 2002 NEC, which is the version in question. While the fundamental principles of electrical safety remain consistent across different editions of the NEC, there can be subtle but significant changes in the specific requirements and interpretations. Therefore, it is crucial to refer to the specific edition of the code that is in effect in the jurisdiction where the electrical work is being performed. The 2002 NEC was a significant addition in terms of introducing and refining several key concepts in electrical safety. One notable change was the increased emphasis on arc fault circuit interrupter, or FSI protection. While FSI protection had been introduced in earlier editions of the code, the 2002 NEC expanded its application to include more areas of dwelling units, including bedrooms. The rationale behind this expansion was to provide enhanced protection against arc faults, which are a leading cause of electrical fires. Arc faults occur when electricity jumps between conductors, creating a high-intensity spark that can ignite nearby combustible materials. Traditional circuit breakers are designed to protect against overloads and short circuits, but they may not always detect arc faults. SI breakers, on the other hand, are specifically designed to detect the unique characteristics of arc faults and trip the circuit before a fire can start. In the context of the scenario presented, the fact that the 15-amp circuit is arc fault protected provides an additional layer of safety that should be taken into consideration. While the inspector's concern about the total number of outlets is understandable, the presence of SI protection mitigates some of the risk associated with potential overloads or faults. Another important aspect to consider is the evolution of lighting technology since the 2002 NEC was published. At that time, incandescent lighting was still the dominant technology, and lighting loads typically represented a significant portion of the total load on a branch circuit. However, with the widespread adoption of energy-efficient lighting technologies like compact fluorescent lamps, or CFLs, and light-emitting diodes, or LEDs, lighting loads have decreased dramatically. LED lighting, in particular, offers significant energy savings compared to incandescent lighting, while also providing comparable or even superior light output. This means that a modern lighting outlet with an LED fixture may draw significantly less current than a similar outlet with an incandescent bulb. As a result, the overall load on a branch circuit with LED lighting may be lower than what was anticipated when the 2002 NEC was written. This factor further supports the argument that the electrician should be allowed to have additional lighting outlets on the 15-amp circuit as long as the total load on the circuit does not exceed its capacity. In addition to the specific requirements for receptacle and lighting outlets, the 2002 NEC also includes general requirements for branch circuit loading. Article 210.22 specifies the maximum load that can be connected to a branch circuit. For a 15-amp circuit, the maximum load is typically limited to 80% of the circuit's rating, which is 12 amps. This limitation is intended to prevent continuous overloading of the circuit, which can lead to overheating and premature failure of electrical components. To determine the actual load on a branch circuit, it is necessary to calculate the wattage of all connected devices and appliances. For receptacle outlets, the NEC requires a minimum allowance of 180 volt-amps per outlet. This allowance is intended to account for the potential use of high wattage appliances, even if they are not always connected to the outlet. For lighting outlets, the wattage is typically determined based on the rating of the installed luminaires. Once the total wattage of all connected devices and appliances has been calculated, it can be converted to amps by dividing by the voltage of the circuit. For a standard 120-volt circuit, the formula is amps equals watts divided by volts. If the calculated load exceeds 12 amps for a 15-amp circuit, then it may be necessary to reduce the number of outlets or increase the circuit size to ensure safe operation. In conclusion, the interpretation of Article 220.3b9 and Article 220.3b10 of the 2002 NEC requires a careful consideration of the specific code language, the context of the electrical installation, and the evolution of lighting technology. While the inspector's concern about the total number of outlets is understandable, a strict interpretation of the code suggests that the electrician should be allowed to have 13 receptacle outlets plus any necessary lighting outlets on the single 15-amp circuit, provided that the receptacles are arc fault protected and the total load in the circuit does not exceed the circuit's capacity. It is recommended that the inspector reconsider their interpretation and engage in a dialogue with the electrician to ensure a mutual understanding of the code requirements. Furthermore, it is important for electricians to carefully calculate the load on branch circuits to ensure that they are not overloaded and to stay up to date on the latest changes and interpretations of the NEC. By following these guidelines, we can ensure the safety and reliability of electrical installations in dwelling units and other buildings.